This lesson is about Kubernetes, which is currently the most popular container orchestration engine. Before we begin, you will need to install Minikube on your local machine. For instructions, please see github.com/kubernetes/minikube. You will also need a free user account on Docker Hub. Kubernetes is one of the leading container orchestration solutions on the market. As we learned in the section about modern cloud platforms, Kubernetes is originally built by Google and is natively supported on the Google Cloud Platform. Kubernetes provides tools for deploying and running Docker containers on a fleet of servers, and it enables you to build modern, resilient, large-scale container-based architectures. Like many other container orchestrators, Kubernetes exposes a set of APIs that abstract the management of servers away from the user, enabling teams to create, manage, and destroy complex containerized environments programmatically. This makes container orchestrators like Kubernetes a great platform for modern application environments. Concepts like on-demand environments can be implemented economically and with relatively little effort. The Kubernetes project has published a tool called Minikube, which enables you to run a lightweight Kubernetes cluster on your local machine. Note that the word cluster is a bit misleading here, since Minikube only consists of a single node, but this makes it easy to trial Kubernetes. In this lesson, we'll be creating a local Kubernetes cluster with Minikube and deploying our Hello Node application on it using the Kubernetes management dashboard. There are a few important concepts and naming conventions we need to discuss before starting our cluster. Please note that this is not an exhaustive list, but knowing this is enough for the purposes of this lesson. A pod in Kubernetes is a unit of one or more containers. A pod is a basic unit of any application running on a Kubernetes cluster. A deployment is a way to launch and manage a number of identical pods. A deployment can be scaled up and down and updated whenever you want to deploy a new version of your application. A service in Kubernetes is a connectivity abstraction on top of a deployment. It's a way to refer to a group of pods with a single static IP address. For example, if you were running a deployment of 5 identical web servers across 5 Kubernetes nodes on AWS, you'd set up a service to give you a single endpoint and handle load balancing to all of your web servers. Finally, Kubernetes has a concept of namespaces to create multiple virtual clusters of all these resources. Kubernetes supports configuring all these resources with either YAML or JSON configuration files, or graphically via the Kubernetes dashboard. Let's start up a new Kubernetes cluster using Minikube on the command line. Depending on the operating system you're on, Minikube will use a virtualization technology to start a virtual machine with a single Kubernetes node. Minikube then provides a set of helper commands to easily access the cluster and the services running on it. The command to create a new cluster is Minikube start. Running Minikube start might take a few minutes, but when it's ready, you'll see something like kubectl is now configured to use the cluster. Kubectl is the Kubernetes command line interface, and it can control all aspects of a Kubernetes cluster. For this lesson, we'll be using the Kubernetes dashboard. You can get the link to the dashboard from Minikube with the command minikube dashboard. This will launch the dashboard on your default web browser. When you land on the dashboard, you'll be in the default namespace that is empty. Please note that the Kubernetes dashboard is a work in progress and it doesn't provide the full functionality Kubernetes has to offer. It is, however, just enough for the purposes of this lesson, so let's create a new deployment by clicking the blue Create link on the top right corner. As we don't have a YAML or JSON configuration file yet, we'll create a new deployment using the form. For the app name, we'll write Hello Node. Note that the app name needs to start with a lowercase letter, and it can only contain letters, numbers, and hyphens. Next, we'll give the name of the Docker image we'll run. We'll be using the same image we built earlier on the Docker lesson, but before we can deploy it into a cluster, we'll need to push it to a registry. You remember in the Docker lesson we discussed the registry being the way we can distribute Docker images across many servers. This is exactly what we'll need to do here, as Kubernetes can only pull Docker images from valid Docker registries. Let's jump back to the terminal for a bit. First, we'll use docker tag to append our Docker Hub username on the image tag. We need to do this with Docker Hub, as all images we host need to be under our user account. On the Docker lesson, we built the Hello Node image with the tag hello node:latest. Let's run docker tag to retag the image with our username /hello node:latest. I'm writing get into DevOps as the username here, but you should replace it with your own Docker Hub username. After we've created the tag, we'll need to log into the registry with the command docker login. This is an interactive command that asks you for your Docker Hub username and password, and stores them in a configuration file in your home directory. Now that we've logged in successfully, we can push the image with docker push. Docker push expects one argument, which is the image tag. For this, we'll use our Docker Hub username /hello node:latest. Great! Now we can configure Kubernetes to use our image. Let's go back to the dashboard and write our image tag as the container image. Next, we'll define the number of pods. This setting is for horizontal scaling. If we set this to 2, Kubernetes will run 2 Hello Node applications. This is useful for horizontal scaling and high availability, something we also discussed in the AWS lesson. If we were to run 2 Hello Node applications, Kubernetes will try and place them on different servers in the Kubernetes cluster. This means that if a single server should fail for any reason, the application would still be reachable via the other server. Finally, we'll define an external service. As you remember, the Hello Node application listens on port 8000, so we'll create the mapping from port 8000 to port 8000 here. Now we're ready to deploy. We'll drop to the workloads overview page of the Kubernetes dashboard. On the top we can see our deployment with 0 out of 2 pods up and running. Below that we can see the pods themselves. Both of them are in the pending state, which means that Kubernetes is still launching them on a node. Below the pods we can see a replica set. A replica set is an underlying concept Kubernetes uses to facilitate updates of deployments. We won't need to worry about that in this lesson. When we reload the page, we can see that both the deployment and the pods are all green. This means the application is successfully running on Kubernetes. The final thing we need to do is get the endpoint of the service, so we can connect to our Hello Node server. As we're using Minikube to run this cluster, we'll need to get the service endpoint from Minikube with the command minikube service hello node. Just like with Minikube dashboard, the minikube service command will open the service endpoint in our default browser. Well done! You've just deployed your first application in Kubernetes. Next, you can try scaling the Hello Node deployment up and down to see the number of running pods change. In a later lesson, we'll be building a simple continuous deployment pipeline that builds, tests, publishes and deploys an application into a Kubernetes cluster automatically whenever there's changes to the application code. After you're done testing, you can destroy the Kubernetes cluster with the command minikube delete. Thanks for following.